Welcome everyone to the April 29th OMR Architecture Meeting. Today we have one topic to discuss. So Philip's going to revisit some work that we had talked about late last year on centralizing the opcode enum of the opcode enums. So Philip, feel free to take it away.
Zero. Can you hear me?
Yes.
Awesome. Okay. Just going to share my screen. It might be easier. Can you see my browser?
Yes.
Yes.
Cool. Okay. So I guess late last year, we had a Slack conversation to, I guess, propose cleaning up our centralized upcoding enums, which was some work that was done late in the fall. So the main motivation behind this work was to make it easier for downstream projects to override OMR evaluators and to eliminate some of the, I guess, preprocessor tricks that we're doing at the moment. I have, and another part of the reason was that our evaluator names are kind of all over the place on different cogens. I think I gave an example last time of the long unsigned negative evaluator having, different name on every single platform. So if you want to see the implementation of that evaluator across platforms, you kind of have to dig through all the layers to find where this is actually implemented. So an idea was brought forth to, I guess, canonicalize or standardize the name for evaluators across all the cogens. And the initial proposal was to implement a function which has the opcode and then followed by the keyword evaluator after. And every single opcode follows the same nomenclature. This does introduce quite a bit of, I guess, boilerplate code, which might be unnecessary, and it would require inlining some of the implementations into these stub functions. And at a later point, there was an alternative solution discussed, which we can use kind of these opcode macros to more or less achieve the same effect without the naming benefit for our downstream projects. So what I did was, I guess late last year, I prototyped how this would look on x86 just to get an example. And one of the concerns we had at the time was the footprint growth, which I measured to be about 0.7% using OpenJ9 as an example. And that's for every single evaluator. I think since then we've eliminated some opcodes and there's more coming with the DFP deprecation as well. So I expect that number to probably be even like 0.6 or 0.5. So I don't think there's too much concern on the footprint side of things. I guess it's more so on, it's quite a lot of code that we're introducing. So I wanted to bring it up on another call today to have people go back and look at the two PRs that are open. And I guess we can make a call whether we want this now or should we perhaps go with the simpler preprocessor, I guess, not sure what to call this. It's still kind of a hack to let our downstream projects override things. So I have the two PRs open just to give you a sense of what this looks like. It's a really mechanical change, but it does introduce quite a bit of code. So today, for x86, I just made the change here. So what we have today is we have all of these preprocessor defines. For example, for an aconst evaluator, we have this underscore aconst evaluator define, which maps to the actual function that we need to call. And we have that for every single opcode that we have in the code base. And at the very end, we use our centralized opcode table to map these, to map the function pointer which executes when we want to evaluate an opcode to these underscore methods. So it's going to be underscore and then the opcode name and then followed by evaluator. And of course, that'll get replaced with one of these, and this will get replaced with the actual evaluator C++ function at compile time. The unfortunate side effect of this is that you can't actually override evaluators in downstream projects because you'll have a naming clash. Because, for example, if I want to override the byte swap evaluator, well, it's already defined in OMR and it's going to go here no matter what. So I can't actually override that in a nice way at the moment. So what I guess the current proposal that we have introduces quite a lot of boilerplate. So rather than doing those underscore methods, we just implement all the functions evaluators with just the opcode and then evaluator in the name. And then literally all of these are just stubs calling whatever was on the right-hand side of those processor defines. So for example, the Lmax evaluator today in the processor stub is calling the min-max evaluator function. And in the new world, we just have a stub function calling the same thing. So it's just a knob change effectively. Of course, over time, we'd probably want to merge things like this into the actual Lmax evaluator, if that makes sense. And most of the time it actually does, unless we share a lot of the code for each and every evaluator. And on the OpenJ9 side, how this looks is we actually get rid of the entire tree evaluator table. So these are no longer needed anywhere in OpenJ9. And for the opcodes that are defined in OpenJ9, we simply just define the functions in the same nomenclature. So I guess all these are going to go away soon. But for the dfconst evaluator, you just need to define the function and the implementation of that, whatever that may be on your particular platform. That's it. So I guess the revisit portion of these is just to get people looking at the two PRs, and we can make a call on whether we actually want to proceed with this or should we just re-implement our hash defines to be able to override these evaluators at compile time. Maybe as a stepping stone, maybe sometime in the future we can take a look at doing the full thing. So I guess I'll stop here and open it up for discussion.
Were there any name conflicts that came from sort of the evaluator already being named according to this pattern, and then it required not adding the the function
There
that
was
would just
quite a
call
lot of
itself?
those cases. I just wrote a script which basically looked for that, and then it just didn't generate anything. But in a lot of the cases where we do have like a one-to-one mapping, of course I didn't do it here, but if we had a one-on-one mapping to, I don't know, I can't really find an example. We could just inline, for example, if this function was only used once, we can just inline it into here, and then there would be exactly no boilerplate.
Yeah, that makes sense.
Yeah, I mean, I guess it's something we could all look through the what you have there, and perhaps on the next call we can, um, if we haven't done it sooner, we can make a call on this one.
Yeah,
go
I
through.
think it is quite a number of lines of code that we're introducing. I wasn't expecting it to be this much. So it might even make sense to do the preprocessor if def first as a stepping stone, just to get rid of the cruft in our downstream projects, and then we can look towards standardizing the names at a later point.
It could be a lot less code introduced if the any of that single use inlining is done, or I guess you could think of it as for a function that's only used for one opcode, just renaming the function instead of introducing a wrapper.
Right. Yeah.
That might already drastically reduce the amount of additional code.
Yep. Yeah. The reason I don't think I probably want to do this in these PRs is it's quite mechanical and could be error prone. But you're totally right.
But I do like the naming property. I'll say that I like the overall thing here, where if you want to specialize something, it's there, because you can call the OMR implementation. It has a path to it, right? And then if you want to know, well, I don't know about the long unsigned negate. I guess that's the same as signed negate. But you want to know what the evaluator is for something, you just go that thing evaluator, right?
Yeah.
That's great.
Yeah, that was the original intent of all this work, just to make it easier to find.
Yeah,
every
there've
evaluator
been
on every platform.
There've been a lot of times I've had to sort of chase down, oh, where's the evaluator for this, right?
Yeah, that's a nice feature for sure. And as Philip mentioned, there has been some work happening lately to reduce the size of the IL opcode table in the first place. So at least driven from the OpenJ9 side, Philip's been removing a lot of the the decimal code there. It's not going to impact OMR too much, but there will be some things spilling over. And then all the opcodes that I talked about 2 weeks ago, we got rid of those already. So the OMR opcode table is down to 653, something like that right now, with some possibility of further shrinkage. But yeah, I like the consistency idea for sure. So let's all take a to-do to look through the code that he's put together and make a decision on it within a couple of weeks.
Yep, sounds good to me.
Okay, any other discussion on this topic? It was the only topic, so it's going to be a somewhat short meeting this week. So I guess if there's nothing else, we can call it now. And I've got the agenda created for the May 13th meeting. So if you have a topic to add there, please add it to the agenda and we'll move forward. Okay, thanks everyone for calling in today. See you in 2 weeks.